Hello everyone, welcome back. Let's talk about another medium problem on Leetcode today. The number of the smallest occupied chair, Leetcode 1942. In this problem, there is a party where n friends numbered from 0 to n-1 are attending. There are infinite number of chairs in the party that are numbered from 0 to infinity. When a friend arrives at the party, they sit on an occupied chair with the smallest number. For example, if chairs 0, 1 and 5 are occupied when a friend comes, they will sit on chair number 2. When a friend leaves the party, their chair becomes unoccupied at the moment they leave. If another friend arrives at the same moment, they can sit in that chair. We are given 0 index 2D array times where times I is equal to arrival I, leaving I, indicating the arrival and leaving time of the ith friend respectively, and an integer target friend. All the arrival times are distinct. Then we should return the chair number that friend number target friend will sit on. Then in example 1, for the given times and target friend equal to 1, we return output as 1 because friend 0 arrives at time 1 and occupies chair number 0. Then friend 1 arrives at time 2 and occupies chair number 1, and that's why output is also 1. And now at time 4, friend 0 leaves, but friend 2 comes in. So chair 0 is unoccupied, and that's why friend 2 now sits on chair 0 because that's the smallest available chair now. So that's how the whole logic will continue, but we only care about target friend equal to 1, and that's why we will return 1 as our answer. So to summarize, the idea is that we are given bunch of intervals. Each interval has two values, the arrival time or the start time and the leaving time or the end time. Each interval corresponds to a person or a friend, and each person arrives and leaves the party at a specific time. Now the given array may or may not be sorted, and in order to process the times array, it is important that the times are in the chronological order, and that too they should be sorted based on the arrival times, since the friend needs a chair at the time of arrival. Like in example 2, we can see that the times are not sorted, and target friend 0 comes the latest to the party, but here it shows up like they are the first in the party. So to fix this, we should sort the times based on the arrival times. But sorting the array rearranges the order of friends, which means target friend index cannot identify the target friend directly. So to fix this, either we can create a new array where we can add the start time, the end time, and the index of each time before sorting, or store the arrival time of the target friend because it is given that arrival times are unique. So by storing the arrival time, we can identify the target friend in the sorted array. And now after the sorting, if this is the first person that arrives, we give them chair 0. Similarly, if this is the second person, we give them chair number 1, and so on. And although we initially assume that there are infinite number of chairs, but in practice we only need one chair for one person. So at maximum we will need n chairs, given we have n friends. But there's a catch that the smallest number chair that becomes available needs to be reassigned as soon as it is free, right? So for example, if one person leaves at time 4 and another person arrives at time 4, then the next arriving person can take just free chair instantly. So this becomes like a pool of chairs where we want to pick up the chair with the minimum number. And now for this, which data structure comes to the mind? And the answer is MinHeap, right? So what we can do is we can actually add 0 to n-1 chairs to this MinHeap. And when the friend arrives, we occupy the chair, or we pick up or remove one chair from the pool. And as soon as the friend leaves, we give it back or offer it back to the MinHeap. So now when the next friend comes, they will pick up the chair with the minimum number. And now the question is, how can we deal with the occupied chairs? And here we can actually employ multiple data structures. One way can be that we can actually use a map where we can actually store the friend index and the corresponding occupied chair number. So as soon as friend leaves, we remove this friend from this occupied map and give this chair number back to the min heap. But this will involve additional space as we now have to store friends index with each time, right? And I have covered this solution in my post. Please check it out. But to optimize this, what we can do is we can again use min heap for that. So what we can do is we can actually store the leaving time and the corresponding occupied seat in the min heap, because this way we don't have to worry about the individual friend, just their leaving time. And as soon as they leave, we have to free up the chair. So now our logic becomes simple. First, we will sort the times based on the arrival time. Then we will have two heaps. One can be like a occupied heap and another can be like an available heap. And as soon as the friend arrives with their starting time and ending time, we will check at their starting time if there are some friends in the occupied heap whose departure times are less than or equal to current friend's arrival time. If yes, then we can free up those chairs and put it into the available heap. And now we will pick up the smallest available chair for this friend and assign that chair to it. And if the current friend's arrival time is equal to target friend's arrival time, then we will return the assigned chair number as our answer. We don't have to process all the times. So now let's jump into the code part. First, let's store the arrival time of the target friend so that we can sort our array. And now we can sort the times array based on the arrival time. And we can use a comparator for that. Now we can create the mini heap to store the available chairs. And in Java, we can use priority queue implementation. And now we can just loop from I equal to 0 to n, where n is the times length, and add all the chairs from 0 to n minus 1. Now we will create another mini heap to store departure time and corresponding associated chairs so that we can free them up when the friend departs. And for that, we can use an integer array where we can store departure time at 0th position and allocated chair at first position. And for that, we will pass the comparator. So we want the smallest departure time at the top of the heap. Maybe I should use n as a variable for times length because again I have to loop on the times array for processing all the times. So now we will start processing each friend in the times array. So before assigning a smallest available chair to the current friend, we have to free up all the chairs where the occupied friend's departure time is below current friend's arrival time. So we will check if the priority queue dealing with occupancy is not empty and the element at the top of the priority queue has a departure time less than or equal to current friend's arrival time, then we should free up those chairs because they would have already left. So how can we do that? We can just say available dot offer chair for the past departure time, which is stored at index 1. Now, once we have freed up all the chairs, we will check if we have reached the target friend, and we can do that just by checking if current friend's start time is equal to target friend start time. And if yes, then we need to return the smallest element. So what we can do is we can just break out of the loop. And now we can return the top of the available min heap as the smallest chair for the target friend. Also note that I could have returned from here itself, but then I would have to return -1 here because otherwise Java compiler would have complained. But if this friend is not a target friend, we will assign the smallest available chair from the available min heap. And we can do that by storing current friend's end time or departure time and minimum available chair number from the available min heap. So that's it. Now let's run this code. I should be using diamond operator here. Otherwise, priority queue will consider itself container of objects rather than integer arrays. Now I think it should be okay. Let's submit this code. Cool. In terms of time complexity, it will be O of n log n, primarily coming from the sorting. And then when we are going through each element in the sorted times array, that again takes O of n log n time because removing or adding a minimum element to the min heap takes O of log n time. And then we are doing it for n elements. So because of this, the time complexity is O of n log n. And in terms of space complexity, it will be O of n because we are storing n chairs in the available min heap and then also the similar amount of chairs in the occupied min heap as well. So that's why the space complexity is O of n. So that's it. I hope this video was useful to you. If it was, please like, share and subscribe. The code link is in the description below. Thank you for watching. See you next time.